You know what kills me about NASCAR's restrictor plate era? It wasn't the speed limits. It wasn't the pack racing. It was watching the smartest engineers in motorsports turn into outlaws. And nobody, played that game better than the hollow bolt bandits of the late 1980s. Picture this. It's 1988, Daytona International Speedway. You're a crew chief watching your perfectly built 700 horsepower engine get neutered down to 450 horses because NASCAR slapped a restrictor plate between your carburetor and intake manifold. That aluminum plate with 4 tiny holes is literally choking your engine. The engineering equivalent of breathing through a straw while running a marathon. Your driver's out there in a 200-mile traffic jam, and there's not a damn thing you can do about it. Or is there? This is the story of how one anonymous mechanic, whose identity remains protected to this day, discovered an engineering loophole so elegant, so simple, and so devastatingly effective that it took NASCAR years to figure out what was happening. We're talking about hollow bolts, 4 modified fasteners that turned also rans into winners and made NASCAR's technical inspectors look like fools. To understand why this trick was pure genius, we need to travel back to February 1987. Bill Elliott had just run 809 miles per hour at Talladega. Let that number sink in. A 3,400-pound stock car hitting speeds that made IndyCar look slow. Bobby Allison's crash that same year sent his car airborne into the catch fence, nearly taking out dozens of fans. NASCAR had 2 choices: redesign every track in America or slow the cars down. They chose option 2. Enter the restrictor plate, a piece of aluminum roughly the size of a playing card, 1/16 of an inch thick, with 4 precisely machined holes. Those holes measured exactly 29/64 of an inch in diameter for the superspeedways. The physics were brutally simple. Limit the air entering the engine, limit the power it can make. An engine needs 3 things to make power: fuel, air, and spark. Take away the air, and you've got an expensive noisemaker. But here's where it gets interesting. The restrictor plate bolted between the carburetor and the intake manifold using 4 mounting bolts. Standard 5/16-inch bolts, nothing special about them. NASCAR checked the plate dimensions religiously. They used go-no-go gauges on the holes. They verified the thickness. They made sure teams weren't using trick plates that flexed under vacuum to open up the passages. They thought they had every angle covered. They were wrong. See, those mounting bolts passed right through the airflow path. The bolts themselves were inside the airstream, between the carburetor and the engine. And that's when our anonymous genius had his eureka moment. What if the bolts weren't solid? The modification was beautifully simple. Take a standard mounting bolt, chuck it up in a lathe, drill a hole straight through the center, starting from the threaded end. Stop just short of the head so it still looks normal from the top. You've now created a hollow tube that runs the entire length of the bolt inside the air passage. The walls of the bolt might only be 1/16 of an inch thick, but that hollow center creates a bypass channel. Now here's the engineering brilliance. 4 bolts, each with a 3/16-inch hollow center, gives you about 0.11 square inches of additional flow area. Doesn't sound like much, right? But when you're dealing with engines spinning 9,000 RPM, trying to suck air through a restrictor plate, that extra flow is worth its weight in gold. Or in this case, horsepower. The teams running this setup figured they were getting an extra 15 to 25 horsepower. At Daytona and Talladega, where the draft keeps everyone bunched up, where races are decided by thousandths of a second, 20 horsepower might as well be 200. It's the difference between leading the pack and watching someone else's bumper all day. But wait, there's more. The really clever teams didn't stop at just drilling out the bolts. They experimented with different internal diameters. They tried tapering the holes, wider at the bottom, narrower at the top, to accelerate the airflow. Some teams allegedly experimented with rifling the inside of the bolts, creating a spiral that would spin the air as it passed through. The theory was that spinning air would maintain velocity as it entered the intake manifold. The carburetor spacer itself became part of the conspiracy. Teams would machine special pockets around the bolt holes, creating tiny plenums that helped direct air into the hollow bolts. From the outside, everything looked completely stock. The spacer was the right thickness. The bolts appeared normal. But inside, it was a carefully orchestrated airflow management system. NASCAR's inspectors were going crazy. They knew something was up. Cars that should have been mid-pack runners were suddenly competing for wins. Qualifying speeds were higher than the math said they should be. During post-race inspection, they'd tear down the carburetors, measure the restrictor plates, check everything they could think of. All legal. The beauty of the hollow bolt trick was its invisibility. Unless you physically removed a bolt and looked at it from the bottom or cut it in half, you'd never know. And who's going to destroy a bolt during routine inspection? NASCAR was checking dimensions, not doing metallurgical cross-sections. Think about the manufacturing precision required here. These weren't backyard mechanics with drill presses. The bolts had to be perfectly concentric. The walls had to be thin enough to maximize flow, but thick enough to handle the torque specs without crushing. Too thin, and the bolt collapses when you tighten it. Too thick, and you're not getting enough extra airflow to matter. The sweet spot was about 1/16 inch wall thickness, which required precise machining and high-quality steel. Some teams allegedly went even further. There were rumors of bolts made from exotic alloys, titanium or special steel compositions that allowed for even thinner walls while maintaining strength. The cost? Astronomical. We're talking about spending thousands of dollars on 4 bolts. But when a win at Daytona paid out $200,000 in 1988 money, and sponsorship bonuses could double that, the investment made sense. The technical challenge extended beyond just making the bolts. Teams had to calibrate their entire engine package around this extra airflow. The carburetor jetting needed adjustment. The ignition timing curves had to be modified. The camshaft profiles that worked best with a restricted engine were different from what you'd run with that extra air. It was a complete systems engineering approach to cheating. Here's a number that'll blow your mind. Engineers calculated that at 7,000 RPM, those 4 hollow bolts were flowing an additional 50 cubic feet of air per minute. That's enough extra air to fill a phone booth every minute. In an engine where every cubic inch of airflow is fighting through that restrictor plate, that's massive. The teams also discovered that the hollow bolts affected the air-fuel mixture distribution. The extra air coming through the bolts created turbulence in the intake manifold that actually improved cylinder-to-cylinder mixture distribution. So not only were they getting more air, they were getting better combustion efficiency. It was a double win. NASCAR finally caught on in 1991. How? The story goes that a disgruntled former crew member from one team tipped off NASCAR officials. He didn't just tell them about the trick, he brought them a cutaway bolt to prove it. Can you imagine being the NASCAR inspector who finally saw that? 3 years of wondering how these teams were beating the system, and it was right there under their noses the whole time. The crackdown was swift and severe. NASCAR didn't just ban hollow bolts. They mandated that teams use specific bolts provided by NASCAR. These weren't just any bolts. They were specially manufactured with a unique head marking that couldn't be counterfeited. NASCAR would literally hand out sets of 4 bolts to each team before qualifying and races. After the race, those exact bolts had to be returned. But here's the thing about racers. Tell them they can't do something, and they'll find 3 new ways to do it better. When NASCAR started providing the bolts, teams tried everything. They attempted to drill out NASCAR's bolts and plug the tops. They experimented with special coatings that would burn away during the race, opening up passages. One team allegedly tried using a chemical treatment that would dissolve the center of the bolt over time, creating the hollow cavity during the race itself. None of these follow-up tricks worked as well as the original hollow bolt concept. NASCAR had gotten wise. They started using different metallurgy for their bolts. That would show obvious signs of tampering. They'd randomly swap bolts between teams. They'd weigh the bolts before and after races. The party was over. The hollow bolt era represents something bigger than just creative rule bending. It showcases the fundamental conflict between regulation and innovation in racing. NASCAR wanted close competition and safe speeds. Teams wanted to win. Engineers were caught in the middle, their creativity channeled into finding loopholes rather than advancing technology. Consider the engineering talent wasted on circumventing rules. The same minds that figured out hollow bolts could have been developing safer cars, more efficient engines, better aerodynamics. Instead, they were playing cat and mouse with the rulebook. It's the racing equivalent of hiring Einstein to do your taxes. The restrictor plate itself became a masterclass in unintended consequences. NASCAR wanted to bunch up the field and create exciting racing. They got that, along with massive crashes that launched cars into the air. They wanted to level the playing field. Instead, they created an arms race of who could cheat most creatively. But let's talk about the engineering elegance of the hollow bolt solution for a moment. It didn't require any exotic technology. It didn't need computers or wind tunnels or million-dollar facilities. Just a good lathe, an understanding of fluid dynamics, and the courage to try something nobody had thought of before. It was accessibility meeting ingenuity. The trick also highlighted a fundamental principle of engineering. The best solutions are often the simplest. While other teams were trying complex valve timing tricks or exotic fuel blends that skirted the rules, someone looked at 4 ordinary bolts and saw opportunity. That's not just smart racing, that's brilliant engineering. Modern NASCAR has learned from the hollow bolt era. Today's inspection process uses tools that would seem like science fiction to 1980s inspectors. Coordinate measuring machines that can detect variations of thousandths of an inch. Ultrasonic testing that can find internal modifications without destroying parts. Chemical analysis that can detect non-standard materials. The hollow bolt trick couldn't happen today. Or could it? Racing engineers are still finding ways to bend rules. They're just more sophisticated now. Computer-controlled suspension components that change spring rates based on speed. Aerodynamic elements that flex at specific velocities. Engine mapping that adjusts power delivery in ways that are nearly impossible to detect. The game continues, just with different rules and tools. The hollow bolt story also raises ethical questions about competition. Is creative interpretation of rules actually cheating, or is it innovation? If the rulebook doesn't specifically say bolts must be solid, is making them hollow wrong? These aren't just racing questions. They're the same dilemmas faced in business, technology, and life. Where's the line between clever and corrupt? For the teams that ran hollow bolts, it wasn't a moral question. It was survival. In NASCAR's top tier, the difference between first and 10th place could mean millions in sponsorship dollars. The difference between keeping your ride and losing it. When your livelihood depends on finding an edge, you find an edge. The anonymous mechanic who first drilled out those bolts, he's never been officially identified. There are rumors, of course, whispered names in garage areas, but nobody's ever stepped forward to claim credit. Maybe because NASCAR's statute of limitations on rules violations is unclear. Maybe because the racing community protects its own. Or maybe because the best tricks are the ones where the magician never reveals the secret. What we do know is that between 1988 and 1991, hollow bolts were NASCAR's worst-kept secret, that somehow stayed secret from the only people who mattered, the inspectors. Crew chiefs would share knowing looks. Engineers would exchange subtle nods. Everyone knew somebody was doing it. Most suspected everyone was doing it. It was mutually assured destruction if anyone talked. The technical specifications of those modified bolts have become the stuff of legend. Some claim the best ones were gun-drilled to tolerances of plus or minus 0.01 inches. Others say teams experimented with EDM, electrical discharge machining, to create perfectly smooth internal surfaces that maximized flow. The truth is probably somewhere in between, but the mythology has grown with time. Here's something that'll really bake your noodle. Engineers have retroactively calculated that if every car in the field was running hollow bolts, the competitive advantage would have been zero. Everyone would have had the same extra horsepower. The racing would have been exactly the same, just slightly faster. The only winners were the teams that figured it out first, and the manufacturers making specialty bolts at premium prices. The hollow bolt trick also demonstrated the importance of tribal knowledge in racing. This wasn't something you'd find in any textbook. No engineering school taught creative carburetor fastener modification 101. It was passed from mechanic to mechanic, team to team, a secret tradition of speed. The kind of knowledge that only exists in the minds and hands of people who live and breathe racing. Today's NASCAR teams look back on the hollow bolt era with a mixture of nostalgia and amazement. Nostalgia for a time when a clever mechanic with a drill could outsmart million-dollar inspection procedures. Amazement that it took NASCAR so long to catch on. It's become a benchmark story, the one old-timers tell the young engineers to illustrate that innovation isn't always about technology. Sometimes it's about seeing what everyone else overlooks. The physics behind why hollow bolts worked so well is actually fascinating. In fluid dynamics, there's something called the Venturi effect. As air accelerates through a restriction, its pressure drops. This pressure drop can actually help pull more air through adjacent passages. The hollow bolts created mini Venturi tubes right next to the main restrictor plate holes. The interaction between these airflows created complex pressure gradients that further enhanced the total flow. It wasn't just about the extra area, it was about how that area influenced the entire airstream. Teams that ran computational fluid dynamics simulations years later with modern computers discovered that the hollow bolt design was nearly optimal for its purpose. The straight-through design, while simple, created the least turbulence and maximum flow for the available space. Sometimes the first idea really is the best idea. The cost-benefit analysis is staggering when you break it down. 4 custom bolts, maybe $2,000 in 1988 dollars. Extra horsepower gained, $20-25. Cost per horsepower, $80-100. Compare that to traditional engine development, where you might spend $50,000 to gain the same power through legitimate means. The return on investment was astronomical. No wonder teams were willing to risk penalties. But the real cost wasn't monetary. It was the breakdown of trust between NASCAR and its teams. The hollow bolt era contributed to an US versus them mentality that persists today. Every new rule is seen as something to be circumvented. Every inspection procedure is viewed as a challenge to overcome. The relationship became adversarial rather than collaborative. Some argue this was actually good for the sport. The technical cat-and-mouse game created storylines. Fans loved hearing about clever cheats almost as much as they loved watching races. It added a layer of intrigue to what could have been just cars turning left. The hollow bolt story became part of NASCAR folklore, right up there with Junior Johnson's Banana Car and Smokey Yunick's 7/8 scale Chevelle. The engineering legacy extends beyond just racing. The hollow bolt concept has been adapted for legitimate uses in other industries. Aerospace engineers have used similar principles for weight reduction in non-critical fasteners. Industrial designers have incorporated hollow bolts in applications where weight and airflow both matter. Sometimes racing's rule benders accidentally invent something useful. Let's put this in modern context. Today's NASCAR Cup Series cars make about 670 horsepower unrestricted, 510 horsepower with the tapered spacer at superspeedways. That's still a massive restriction, but it's managed through precise fuel injection and electronic controls that would have seemed like magic to 1980s teams. The principle remains the same: limit the air to limit the power, but the execution is light years more sophisticated. The inspection process has evolved too. Modern NASCAR inspection is a multi-million-dollar operation involving laser scanning, template grids, and enough measuring equipment to outfit a small engineering firm. The days of hiding modifications in plain sight are largely over, but teams still try. They have to. It's in their DNA. The hollow bolt story teaches us something fundamental about human nature. Give people a constraint, and they'll find a way around it. Make a rule, and someone will find a loophole. It's not just about racing. It's about the unstoppable force of human creativity meeting the immovable object of regulation. Sometimes creativity wins, at least for a while. For young engineers entering motorsports today, the hollow bolt era serves as both inspiration and warning. Inspiration that simple solutions can beat complex problems. Warning that getting caught can end careers. The mechanic who first drilled out those bolts probably thought he was just solving a problem. He ended up creating a legend. The technical details that have emerged over the years paint a picture of remarkable precision. The best hollow bolts maintained wall thickness uniformity within 0.05 inches around the entire circumference. The internal surface finish was polished to near-mirror quality, reducing boundary layer friction. Some teams allegedly experimented with hydrophobic coatings on the internal surfaces, though the benefit at those air velocities was probably negligible. The most successful teams didn't just drill bolts. They created entire systems. Custom carburetor spacers with carefully designed air passages, intake manifolds modified to take advantage of the extra flow. Camshafts ground with profiles that utilized the additional air. It was holistic cheating, if there is such a thing. Every component optimized around those 4 hollow bolts. NASCAR's response to the hollow bolt scandal changed how they wrote rules. Instead of saying what you couldn't do, they started specifying exactly what you must do. Bolts must be solid. Bolts must be from this specific manufacturer. Bolts must have this exact weight. The rulebook went from guidelines to encyclopedic specifications, all because someone got creative with a drill press. The cultural impact rippled through the sport. The hollow bolt trick became a litmus test for how crew chiefs viewed rules. There were those who saw it as cheating, pure and simple, and those who saw it as innovation within ambiguity. That philosophical divide still exists in every racing paddock in the world. Is it cheating if the rule doesn't specifically forbid it? In the end, the hollow bolt era lasted roughly 3 years. 36 months where 4 modified fasteners could turn a midfield car into a winner. In the 100-year history of automobile racing, it's barely a footnote. But for those who were there, who knew the secret, who watched inspectors tear apart carburetors while missing the obvious, it was everything. The anonymous mechanic who started it all? He's out there somewhere, maybe retired, maybe still in the sport, watching modern NASCAR with its tapered spacers and electronic fuel injection, probably chuckling every time commentators talk about teams pushing the envelope. Because he knows what pushing the envelope really looks like. 4 bolts, hollow centers, 25 horsepower, and a secret that changed racing. When you think about American racing innovation, you think about overhead cams and fuel injection and aerodynamics. But sometimes the greatest innovations aren't about what you add, they're about what you take away. In this case, the center of 4 bolts. Material that weighed maybe 2 ounces total. 2 ounces that were worth their weight in champagne and trophies. That's the beautiful paradox of the hollow bolt story. The most elegant engineering solution to NASCAR's restrictor plate rules was also the simplest. Not exotic materials or complex mechanisms, just the absence of metal where metal was expected to be, a void that became victory, empty space that was worth everything. The next time you watch a NASCAR race at Daytona or Talladega, and you see those cars bunched up in a pack, engines screaming at the limit of what the rules allow, remember the hollow bolts. Remember that somewhere in that garage area, there's probably an old mechanic who knows exactly how to make those cars faster. He just can't do it anymore. The bolts are solid now, the inspectors are watching. But the spirit of innovation, that urge to find the edge, that's as hollow bolt strong as ever. What's the most creative bit of rule bending you've ever heard about in motorsports? Drop it in the comments below. And if you enjoyed this deep dive into NASCAR's engineering underground, make sure to subscribe. We're just getting started on the stories of racing's greatest technical tricks.